Hello Math Wizards, welcome to my channel. In this video we will take a closer look at the area formula for a trapezoid, and let's try to answer this question. Why do we add the top and the bottom lengths of a trapezoid together to find the area inside the shape? So go ahead and grab your wand and a piece of paper and let's take a look at a trapezoid. So this one here, we can see that the top length is 5 inches and the bottom length is 6 inches. So following this formula, they're showing us that using the letters A and B, A being the top length and B being the bottom length. You can also write it this way, showing the top length being B1 and the bottom or the base B2. All of that added together times the height and divided by 2. So let's see what the area is inside this shape, and then we'll take a closer look to try to figure out why is it that we're adding this top length to the bottom length to figure out how many square units will fit inside the surface of the shape. So I'm going to go ahead and just pull the values in. I can see here that my top length is 5 inches plus my bottom length is 6 inches times the height. We use this perpendicular line. You can see that is attached to the square corner here, so we know that this is perfectly straight up and down or perpendicular. So this shape is 4 inches tall, and all of that divided by 2 to find the area. So we're going to use our PEMDAS rules and take care of what's in parentheses first. 5 inches plus the 6 inches is 11 inches times the 4 inches for the height, and all of that divided by 2. Now we can go ahead and move further in the PEMDAS rules, multiply or divide. We're going to take care of what's on the top first, and then we'll do the division afterwards. So 11 inches times 4 inches is 44 square inches, and all of that divided in half, or divided by 2. So as you can see, this area here inside this shape, we could fit 22 square inches. Okay, so now let's try to figure out why is it that we're adding this length on the top to the length on the bottom. Well, if we look at the shape, if I wanted to take this length right here and add it to this length right here, I want to try to put them right next to each other. So really the only way to do that is to trim this or cut this in half. So I'm going to take my shape and cut it right through the middle. Now notice as I'm doing this, it chops the height in half. So right now this is 4 inches tall, but when I chop it in half, half of 4 is going to be 2. Now, in order to get this length right next to the bottom length, I'm going to flip it upside down. And when I slide these both together, we can see the shape of a parallelogram. So if you remember, the area formula for a parallelogram is just the base times the height. So our base now, when I flipped this upside down, is 6 plus 5 more inches. And that's why in the trapezoid formula we're adding the base 1 plus the base 2. So now we have 11 inches as the base of this new parallelogram, and then times the height, which is not 4 inches anymore, because remember, it used to be 4 inches tall when we started, but now that we cut it in half, the height is only 2 inches. Okay, so I'm going to put that here. And let's see if we come up with the same answer. So 11 times 2 is 22 inches squared. So as you can see, that is the same answer that we got over here when we used the formula for a trapezoid. So that's the reason why we are taking this height and dividing it by 2. Because we have to, in order to get this to turn from a trapezoid into a parallelogram, we have to chop it in half. And there you have it. that is why we are adding the base 1 or the top of the shape plus base 2 or the bottom of the shape of a trapezoid in order to form a parallelogram. So that's it. That is why we add the top and the bottom lengths of a trapezoid together to find the area inside the shape. So just remember, it's all about the bases.
Because you know I'm all about that bass, no trouble. I'm all about that bass, no trouble. I'm all about that bass.